Let's explore the trigonometric functions, at least for sine and cosine, using the unit circle. This will help us to create the graphs of sine and cosine. What is the unit circle? It's simply a circle whose radius is equal to 1. It makes it easy for us to label points around this circle. We cross the positive x-axis at 1, 0, the positive y-axis at 0, 1, the negative x-axis at negative 1, 0, and the negative y-axis at 0, negative 1. Let's also label the angles whose terminal sides pass through each of these points. And we'll do that in radians. So here on the positive x-axis, the point that goes through, or the terminal side that goes through 1, 0, we are at 0 degrees or 0 radians. The terminal side passing through the point negative 1, 0 is of course at 180 degrees or pi radians. Halfway through, we're halfway between 0 and pi. At 90 degrees, therefore, we are at pi over 2 radians. So we've moved from 0 to pi over 2 to 2 pi over 2. 2 pi over 2 simplifies to pi, and that makes this 3 pi over 2. We're counting by pi over 2 every time we move 90 degrees. And of course, 0 and 2 pi radians are coterminal angles. Let's look at the trigonometric functions at each of these points. And we'll copy these down here. So between 0 and pi, we have pi over 2. And between pi and 2 pi, we're at 3 pi over 2. Let's look at the sine of each of those angles. And then later we'll look at the cosine. Let's write ourselves some reminders. The sine of any angle is the value of y over r, regardless, of course, of which quadrant it's in. And the cosine of an angle is x over r. That helps us immensely here because we know that the value of r is always 1. So what is the sine of 0 radians? Well, the sine of 0 is y over r, and the value of y is 0. The value of r is 1. So 0 over 1 is equal to 0. So the sine of 0 radians is 0. What about pi over 2? The sine of pi over 2 is equal to still y over r, except y has a value of 1 here, as does r. So the sine of pi over 2 is 1. The sine of pi, once again, y has a value of 0. So it's 0 over 1 or 0. So we've gone from a sine of 0 is 0, sine of pi over 2 is 1, and now the sine of pi is once again 0. And the sine of 3 pi over 2 is equal to negative 1 over 1, or negative 1. The sine of 3 pi over 2 radians is negative 1. We don't need to calculate the sine of 2 pi because, of course, it's the same as the sine of 0 because those angles are coterminal. So it will also be 0. So the sine of an angle moves from 0 to 1, back down to 0, all the way down to negative 1, and back up to 0. Let's see what happens in between. And then we'll have a look at cosine. In between, if we think about it in terms of degrees, we hit a 45-degree angle. Or it's between 0 and pi over 2 radians. So it's half of pi over 2, or pi over 2 times a half, or pi over 4. So this is the angle of pi over 4 radians. I'll write that into our chart. So to find the rest of them, one easy way to do it is to continue to count by pi over 4 radians, or by 45 degrees. From 0, we get to pi over 4 by adding pi over 4. Pi over 4 plus pi over 4 is pi over 2. When we get to 135 degrees over here, that's 3 times pi over 4 radians that we've traveled, or 3 pi over 4. Then we get to 4 pi over 4 radians, which is just pi radians. Add another pi over 4 radians, and we're at 5 pi over 4. 6 pi over 4 is really 3 pi over 2. And finally, in quadrant 4, once we've added another pi over 4, we get to 7 pi over 4. Adding a final pi over 4 gives us 8 pi over 4. In other words, takes us right back to 2 pi. So try that. Walk around the unit circle, pi over 4 radians at a time. You can walk from 0 to 2 pi that way. So I've tidied up the unit circle a little bit to allow us to focus on the labeled radians. So let's find the sine of pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We expect the sine to have a value between 0 and 1 because the sine of 0 is 0 and the sine of pi over 2 is 1. So the sine of pi over 4, punch that into your calculator, making sure that your calculator is in radians, turns out to be 0.7. Let's try the sine of 3 pi over 4. The sine of 3 pi over 4 is also 0.7. Is that surprising? Not really when we look at the trend. We've gone from 0 to 1 through 0.7, and now we're headed back down to 0, from 1 through 0.7, back down to 0. At this point, you can probably guess what the sine of 5 pi over 4 is. But let's try it. The sine of 5 pi over 4 in your calculator is negative 0.7. We moved from 0 to negative 1 through negative 0.7. And finally, the sine of 7 pi over 4, that's also equal to negative 0.7. None of this should be surprising, at least not the sign, positive or negative, of each of these trigonometric functions. We know that the sine of an angle in quadrant 1 is positive. Same in quadrant 2, but in quadrant 3 and 4, of course, we expected that negative ratio, and that's based on the cast rule. So what we've developed so far is a list of the angles, and I should label this properly, angles from 0 to 2 pi, and their corresponding sine values. The sine of each of those angles is given below. And we see a clear trend from 0 up to 1, down to 0, to negative 1, and back up to 0. Let's have a look at the cosine for each of these same angles. Let's start with the cosine of 0. So the cosine of 0, cosine is, of course, x over r, is going to be 1 over 1. X has a value of 1 at 0, and r will always have a value of 1 in the unit circle. So the cosine of 0 is 1. Of course, the value of x here and the value of r, whether or not they're both equal to 1, they will always have the same value. So the cosine of 0 radians, or 0 degrees, will always be 1. So we see a clear difference already between cosine and sine. Let's do the 90s first, or move around the unit circle by pi over 2 radians. What is the cosine of pi over 2? The cosine of pi over 2, x over r, is 0 over 1, or 0. So cosine started with a value of 1 at an angle of 0, and now we have a value of 0 at an angle of pi over 2 radians. The cosine of pi, that one's negative 1 over 1, or negative 1. Cosine of 3 pi over 2, again, the value of x over r. Here, x has a value of 0 once again. So despite the value of r being equal to 1, the cosine of 3 pi over 2 is 0. We don't need to do the calculation for 2 pi because the angle is coterminal to 0, so we already know that the outcome will be 1. Let's have a look at the in-between values. By which I mean, let's move by 45 degrees, or pi over 4. If you know the value xy value at pi over 4, feel free to use those values. But for this purpose, we can also punch it into our calculator. The cosine of pi over 4, maybe you've just guessed it, should be 0.7. It's the same as the value of sine at pi over 4. And that's because the x and the y coordinate at this 45-degree angle at pi over 4 radians is the same. The x coordinate is 0.7, as is the y. I'm rounding here to 1 decimal place. The cosine of 3 pi over 4 is negative 0.7. There we start to differ from the sine of that angle. We're going from cosine of pi over 2 is 0 to cosine pi is negative 1, so it makes sense that we're passing through negative 0.7. What about the cosine of 5 pi over 4? 5 pi over 4, we're once again at negative 0.7. CAST rule will confirm for us that we expected to see a negative value for cosine in quadrants 2 and 3, but a positive value in 1 and 4. So finally, the cosine of 7 pi over 4, nearly back to 360 degrees or 2 pi radians, has a value of 0.7. So for both sine and cosine, we've now created a table of values that gives us the value of theta compared to the value of the trig function for both sine and for cosine. So what we're going to do is we're going to plot theta on the x-axis and the output of the sine of theta on the y-axis. So that will let us look at the graph of these trigonometric functions.